Alright, so we have a 50 kilogram mass hangs from one end of a rope that passes over a small frictionless pulley. A 20 kilogram weight is suspended from the other end of the rope. Which way will the 50 kilogram mass accelerate? Which way will the 20 kilogram mass accelerate? So since the 51 is heavier, it'll go down and pull the other 21 up with it. Now we're going to draw our own free body diagram for each one. So for the 50 kilogram one, we would have our dot to represent it. We would have mg down, ft up for the rope, and we would show that acceleration goes down because it's going to go down. For the 20 kilogram, we would have the dot for our object. We would have mg down, ft up for the rope, and acceleration would be going up for that object. Next, they drew one here. Instead of the dot, they showed what the masses were. And one thing to take note of is over here, instead of mg, they're writing now m1g and m2g. So now we know the difference between which mass we're talking about. Our ft's up here are equal, so we can keep them as ft. So next, remember there's no special equation for tension, so we need to use net force to find it. Below each diagram, write the net force equation for each mass. So the first one we have sigma F equals m1a. And for that one, if we look at our chart, we have ft in the positive direction and m1g in the negative. So we would get ft minus m1g. And then we would get that m1a is negative because acceleration is going in the negative direction. For the second one, we have, again, ft in the positive direction minus m2g. And our ma would stay as just m2a, positive, because acceleration is positive. So now, when we look at them, what's the difference between the two of them? Well, we've got a negative acceleration and a positive acceleration. And we have an m1 and an m2. So now we have two equations, one for each mass, and two unknowns, ft and a. This means we can combine them together to solve for the variables. So since we each of them have an ft, and the ft's are the same, both of the tension forces, we can get force of tension by itself in each one to make them equal to each other. This is the equation we got for ft of the first object, and this is the second object. To get ft by itself here, we would add m1g to cancel it out, and we would add it on this side too. So now we would get m1g minus m1a, since it's negative. On this side, we would add m2g to cancel it out, since it's subtracted, and add it to this side, since you'd always do it on both sides. So in the end, on this side, we'd get m2g plus m2a. And now, since they both equal ft, we can make them equal to each other, which is what is written down here. Alrighty. So now, we want to get acceleration. That's what we're solving for in the end. What we want to do is we want to get only one a. We want to get them on the same side. So what they did here was they wrote the equations we got up here. And we want to get the a to that side. So we added m1a here to cancel it out and added it there. And that's what they rewrote over here. Next, they want to get the stuff without a's to the other side. So they subtracted m2g there to cancel it out and subtracted it here. So now they rewrote it as m1g minus m2g and m2a plus m1a. So the next step they did was they brought the g1 down, and on this side they took the a's out, like the opposite of distributive property. And then after that they divided by m2 plus m1 on both sides. To cancel those out. So now we have a by itself. The next section just wants us to solve for A. So now we just have to plug in our givens. So we've got M1, which is 50, times G, which is 9.8, minus M2, which is 20, times G, which is 9.8, divided by M1, or M2, plus M1. So now we have 50 times 9.8 gives us 490. 20 times 9.8, which gives us 196. And 20 plus 50, which gives us 70. So now we subtract on the top, 490 minus 196 gives us 294 divided by 70. And when we divide, we get 4.2 meters per second squared for our acceleration. So next, they want to solve for tension. And we remember, tension is the same for both of them. You can pick which equation you want to solve, either the one for M1 or the one for M2 that you got earlier, which is what they did, and they got 280 newtons for both. So it doesn't matter which one you use. Now, when problem solving, they kind of give a general approach. You should read the problem carefully, obviously. Draw a sketch and a free body diagram. Choose a coordinate system. List the known and unknown quantities. Find relationships between them. Estimate the answer. Solve the problem without the numbers, but the variables. Then put the numbers in and solve. And keep track of dimensions and make sure your answer is reasonable. So now we've got the next problem. Two boxes are connected by a cord. A person pulls horizontally on box A with force 40 newtons. So that's this one. The boxes have masses of 10 kilograms and 12 kilograms. Ignore frictions between the box and the table. So the first part they want us to do is A, show the free body diagram for box B. So box B, if we just look back, is this one. So we have the rope to the right, so that's our F10, or I'm sorry, force of tension, Ft. Going down, we always have mg. And then going up, since it's not moving in the up and down direction, we need to have the normal force there to balance out mg. And it's accelerating to the right. Next, we talk about the second box, and this is the one that you're actually pulling on. So we've got mg down, and in this case it's mag. I forgot to mention the other one is mbg. And we have Fn going up because it's not moving up or down. We've got the rope that's connected to the other box on the left, that Ft, force of tension. And to the right, we have the force applied. That's the person pulling it. And it's accelerating to the right. So now we're going to do the same thing. We're going to use the diagram to create our equation. So the first one, sigma F equals MBA, because we're talking about mass B. If we look back at our chart, in the direction we're talking about, we only have one force, Ft. There's nothing on the other side. So our sigma F is Ft, and it equals MBA. And since it's positive, moving in the positive direction, we leave it positive. The second one, if we look, we have force applied minus the force of tension. So we would write that as our forces, force applied minus force of tension equals MAA. And now we need to get Ft by itself so that we can make them equal to each other. So this one, obviously, it's already by itself. We don't have to do anything. This one, we'll have to move it around. So we've got force applied minus force of tension. And we want to, because I don't want to work with negative numbers, I'm going to move the force of tension out of there by adding it to both sides. So it cancels out. So now we have force applied equals MAA plus force of tension. And now we will take out MAA from both sides. And we're left with force applied minus MAA equals force of tension. So next we make them equal to each other. And if we look, we've got MBA from this one equal to the one we got here, which is force applied minus MAA. And now we want to get the A's on the same side so that we can get the A by itself. So we are going to add MAA here and MAA here, and cancel that out. So now we're left with MBA plus MAA equals force applied. And now we're going to do the reverse of the distributive property again and take that A out and put MB plus MA inside. And next, if we move here, we have what we did here was now we divided by MB plus MA to move it to this side to get the A by itself. So now we've got force applied over MB plus MA is going to equal the acceleration. So we've got now force applied, which is 40, divided by MB plus MA, which would be 12 plus 10, which gives us 22. So now 40 divided by 22 will give us 1.82 meters per second squared. And this is all because in part D they asked find the acceleration. Now part D they said find the tension of the cord. So you can choose one of the equations to use. So let's use MBA because that's the least that you need to really work with. We've got force of tension equals our mass of B was 12 times our acceleration of 1.82. So now we're going to get that our force of tension is 21.84 newtons. And you could do it with the other one too if you want. That's that. Now on to the last problem. Two boxes are connected by a cord running over a pulley. The coefficient of kinetic friction between box A and the table is 0.2. Show the free body diagram of box A and box B. Find the acceleration of the system of two boxes. And find the tension in the cord. Something we need to keep in mind, there is friction in this one. So we're going to be dealing with the friction force. So if we look at our free body diagrams, box A, this box right here, we obviously have mg down. It's not moving up or down, and we're going to make that mag, I'm sorry. And we're not moving up or down. So we will make going up force Newton, for normal force. To the right, we have our rope, so that's going to be our force of tension. And to the left, since it's on that table, we're going to have that friction force fighting it. And it's accelerating to the right. And now, box B, this one down here, we have the force of tension up, that's that box. And we have mg going down, and that's going to be mbg. And it's accelerating down, so keep in mind that acceleration is negative. And since there's a lot of work, I'm going to do it over here. So we've got sigma F for the first one equals MAA. Move that over. And if we look at the diagram, we've got Ft to the right and force of friction to the left. So we're going to get Ft minus force of friction equals MAA. And to get the Ft by itself, we're going to add force of friction to each side. We're going to Ft equals MAA plus force of friction. And the only thing we're going to do is, since we know force of friction is mu k mg, we want to plug that in. So we've got tension equals MAA plus mu k times MA, that's the mass we're talking about, G. That's the equation for the first one. Second box, box B, is going to be sigma F equals MBA. And if we look at that box, we have Ft minus MBG equals negative MBA because it's going down in that diagram. So now we're going to add MBG to both sides. And we're going to get FT equals MBG minus MBA. So now we have them both for tension. So now to get acceleration, we need to make them equal to each other. So we're going to rewrite it MAA plus mu K MAG equals MBG minus MBA. And now we want to get this A to this side, so the A's are together, and we want to move this out of there. So we're going to add MBA to both sides. Cancel that out. Ah, weird. And now we're going to be left with MAA plus MBA plus mu K MAG equals MBG. And now we're just going to subtract this out on both sides. So now we have MAA plus MBA equals MBG minus mu K MAG. And now we're going to do the opposite of the distributive property. So A times those. And divide to get the A by itself. So now this is going to be our final equation that equals A, and we just have to plug our numbers in. We get A equals MB, which is 2, 9.8, minus mu K, which is 0.2, times block A, which is 5, times 9.8, divided by 2 plus 5. Now we get 2 times 9.8 is 19.6. 0.2 times 5 times 9.8 gives us 9.8. Divided by 7, which gives us 9.8 divided by 7, which gives us 1.4 meters per second squared. There's your acceleration. So now they want us to solve for the force of tension, so we can choose one of the equations. I'm going to choose to use that the tension equals MBG minus MBA, which we got previously. And now we just have to plug our numbers in. So we've got force of tension equals MB was 2 times 9.8 minus 2 times 1.4. So that gives us 19.6 minus 2.8, which is going to give us a tension of 16.8 newtons. And you could use the other equation too. This one just had less steps. So now the next one says, after we have all those givens, how fast will the block be moving 2.1 seconds after it's released? Remember, it was at rest before it started moving. So we have our V naught was 0, and we're looking for V, and we know our T is 2.1 seconds, and we just got that our A was 1.4 meters per second squared. So now based off these, we know we can use this equation. So V equals V naught plus AT. You can cancel V naught since it was at rest. So V equals A times T, which is 1.4 times 2.1, which gives us a velocity of 2.94 meters per second. So now it says, how far distance will the block MB called 2.7 seconds after it's released. So we're looking for x. We can assume x naught equals 0. We have our time is 2.7 at this point. We know our v naught is 0. And our acceleration equals 1.4. So now, based off this, we can use this equation here. So our x equals x naught plus v naught t plus 1/2 at squared. X naught we said was 0, v naught was 0, so v naught t's canceled. So now all we have left is x equals 1/2 at squared. So now we just have to plug in our numbers. 1/2 times 1.4 times 2.7 squared. So our x equals 1/2, 0.5 times 1.4 times 2.7 squared gives us 7.29. And if we multiply all those together, we get 5.103 meters as your total distance that it fell. So that's that. So review these, try and figure it out, comment as the assignment to let me know what you did or did not understand.